All right, everyone. By my watch little clock on my laptop, looks like it's 8 o'clock. So we're going to get this live stream started. Reminder of what I am using. I am using currently, um, under your review for the test, those 7 problems that I took a picture of. They were called Chapter 5 review problems or Chapter 5 review probs. So that's what I'm going to be going through. I'm going to be going through those 7. If you have other questions that are related to the content on your test tomorrow, feel free to ask those as well. Looks like Tenny is first. Grant's there. Jackson's there. All right, we got some folks. So now that I know we have some people watching, we will get started. If you're watching this later, no big deal too. Should be able to fast forward and kind of figure out if you were doing these things right or not. You're welcome to just watch this afterwards and just kind of use it as an answer key if you're just kind of confirming things. But live's the only way we can ask questions. So let's take a look at what we have. Okay. So first thing that we are taking a look at is an absolute value problem. And we're going to look at the absolute value of 2x plus 3 equals 5. Big thing to remember in this unit is that pretty much everything has multiple solutions. Okay, it has 2 solutions, in fact. Okay, so our absolute value problems are no different. Our absolute value problems, all we're going to do is basically say that, oh, this could be either 5 or it could be negative 5. And we are going to solve both of those separately from each other. Okay, so we're subtracting 3 from both sides. We get 2x equals 2. We're dividing by 2. Then we get x equals 1. Over on our one that equals negative 5, you're doing the exact same math, but you've got a negative 5 over on the other side. So we get 2x equals negative 8. And we get x equals negative 4. Woot. Okay, that's it. So yeah, anyways, that's really it for those. So if it's an absolute value problem, you're splitting it up into 2. Now, I'm going to throw something really quick extra on there. If, I'll do this in a different color, do this in yellow, I guess. If you had absolute value of 2x plus 3, but it was equal to any negative number, think for a second. What would that mean? I'm kind of briefly pausing so you can think about that for a second. Hopefully what you said to anything equal to a negative would be no solution here, okay? So if you've got an absolute value equal to a negative, that would be no solution, okay? Folks, tomorrow your test is very, very short, okay? So I wouldn't be expecting a whole lot, if any, no solutions, but it's a good thing to just keep remembering. All right, our second problem that we are going to tackle, this is another one that we won't need or want to use quadratic formula for. It is 2x plus 1 quantity squared equals 25. And for the most part, this is very, very similar to the last one in terms of the way it's done, except we've got one kind of step at the beginning here, okay? So all we're going to do at the beginning is we're going to take the square root of both sides, okay? And that is to get rid of that squared that's right there. Okay, we're trying to get rid of the squared, okay? And square rooting will get rid of it, all right? When we take the square root of that, we get 2x plus 1, but this is another one in which we have to set up 2 solutions. If you type in square root of 25 into a calculator, it'll simply tell you the answer is 5. But we should know that if we square, root a number, or if we square a number, square 5 or square negative 5, we do get positive 25 either way, so we have to solve for both, okay? Subtract 1, we get 2x equals 4. And we get 2x equals negative 6 over in this one. Divide by 2. and we get x equals 2, x equals -3. Awesome. All right. Looks like William Guy got that one right. That's great. Folks, let's not type the answers into the chat, though. That way people are focusing on paying attention to the work, okay? Because that's the important part, is making sure we're paying attention to the work. So let's not type those into the chat window, okay? Thanks. So next one that we're going to take a look at, and this is yet another one that we are going to try to do without the use of the quadratic formula, and that would be x squared plus 10x plus 25 equals 30. Okay, what we're really trying to do is we are trying to turn it into something that looks very much like our last one. Okay, taking a look, what we're trying to initially do in all of these, when they're not squared for us already, is we're basically trying to make sure is that third number what we want it to be. Okay, as long as we have just a regular x squared at the beginning, which we do in this case, the way we're going to do that is we're going to take that middle number 10, we're going to cut it in half, and we're going to multiply by itself. Okay, so half of 10 is 5. 5 times 5 is 25. So we want our last number to be 25. Here's what's cool. In this particular problem, it is already 25. So that means we can jump straight into factoring. Okay, and we're going to try to factor it into something that looks like that. Okay, and we should know what it factors into, because it's supposed to factor into two of the same number, and we know what those numbers are because we just used them up there to make the 25. So this should factor into x plus 5 squared equals 30. And now we're kind of on the same step that we were at before, okay? Now, I actually need a calculator for square root of 30, okay? I can do a pretty good approximate in my head, but I need a calculator to make sure that I get that right, okay? Taking the square root of 30 gets us 5.48. Okay, so I'm going to get x plus 5 equals 5.48, and x plus 5 equals negative 5.48. We're solving both of those for x by subtracting 5 from both sides. And we get x equals 0.48 and x equals negative 10.48. So Noah asked, can you do one when it doesn't work out like it does with 25? Yes, absolutely. Okay. Folks, we're not taking problem requests necessarily, but as I stated, we are going through the 7 problems that I had up on Google Classroom. Okay, so we are going to do one where that third number doesn't work out quite the way it's supposed to be. Okay, if you have questions on a very specific problem, you'll probably need to get in before school to see me tomorrow. Okay, so taking a look at next one on our docket. So this next one, I said we could use quadratic formula. So actually, you know what I'm going to do though, since Noah just asked to do one without the quadratic formula where that number doesn't work out right, I'm going to skip to number 5 on that set of problems. So that one's actually x squared minus 5x, minus 5x minus 6 equals 0. This is a great example of a problem that where this number is not going to work out right. Okay, so we're still going through those same initial steps where we're taking half that number and we're squaring it. So that's negative 2.5 times another negative 2.5. If I multiply those together, I get positive 6.25. Now, if I look at my third number, it's not positive and it's not 6.25. Okay, so we need to turn that negative 6 into a positive 6.25. Typically, once decimals become involved, especially negative numbers in decimals, I like to do this in 2 steps. You could do it in 1 or you could do it in 2. That's a little bit up to you. So I would add 6 initially just to make that negative 6 turn into a 0. and then I would add 6.25 because that's the number I want it to be. I'm going to do the same thing over on the other side. Okay, when I do that, I get x squared minus 5x plus my 6.25. That's the number I wanted it to be. Over on the other side, I've got to add 0 plus 6 plus 6.25. That's 12.25. Now, I don't need to check that my third number is correct because I've still got that listed right up here, right? I see 6.25 right there. I still see it right there. It's the right number, okay? So kind of knowing that, now I'm going to jump straight into the factoring step, okay? So I get x minus 2.5 squared equals 12.25. Again, I know it's, sorry, I got to erase that. I know it's 2.5 because those are the numbers that I used right up there. Okay. Now I'm taking the square root of both sides. Okay. And I get x minus 2.5 equals square root of 12.25, I believe, is 3.5. Did I get that right? Let me double check just to make sure. I want to use my calculator to be sure I'm not messing that up. Yep, that's 3.5. So I'm doing x minus 2.5 equals 3.5, and I'm doing x minus 2.5 equals negative 3.5. Okay? Adding 2.5 to both sides, I would get 6, and I would get negative 1. Okay? So that was an example of one where that number did not work out correctly, okay? So looking back up, all I did is I turned that negative 6 into a 0 by adding 6, and then I added 6.25 because that was the number I wanted it to be, and I did the same thing on both sides. Okay, alternatively, I could have simply just added 12.25 to both sides because that would have turned my negative 6 into a positive 6.25. Okay? Great. Now I'm going to circle back to the, there were 2 problems, I believe, on those 7 review. Yes, 2, number 4 and number 6, that are good quadratic formula problems. Okay, so we'll tackle both of those, then we'll talk about the discriminant, and then we're all set. So the first one is 2x squared minus x minus 6 equals 0. In quadratic formula, it is exceedingly important that you understand that it has to be equal to 0. Okay, so this is important right there. Really, really important. Once it's equal to 0, you can go into the process of identifying your A, B, and C. Okay? Okay, so I've identified my A, my B, and my C. I get 2, 1, and negative 1 and negative 6. Okay, I got that negative 1 from right there. Okay, folks, I am going to stop. We really got to stop with the emojis and just the random posts. This is for asking questions about math. If you don't have any questions on the particular problem, then that's okay. But then we don't need to post anything. Okay, thank you. So 2, negative 1, and negative 6. Okay, I will plug that into the quadratic formula. Folks, I'm not going to give you the quadratic formula on your test tomorrow. That is not going to happen. Okay, so you need to make sure you have this memorized at the very least often enough, well enough, I should say, not often enough, well enough to be able to get it on your test right away. Okay, so plug those into your formula. Okay, And again, as I showed you in class, I like to use parentheses around wherever I am plugging in numbers for variables. So everywhere where I've got one of my b's, I'm putting a -1 in parentheses. Everywhere I've got my a, I'm going to put a 2 in parentheses. Everywhere where I've got my c, I'm going to put a -6 in parentheses. Okay? All right. So all I did is plug the numbers in. Now what I typically suggest that you do is basically just do the math that's underneath the square root. So I typically will type in just what's underneath the square root, not with all the, with the square root symbol around it, but just the math that's underneath the square root and get a simple number there, okay? So when I do that, I get 49. And a couple other things that I'll simplify to. Down at the bottom, I get 2 times 2 is 4. And up where I have my -1, I get 1. Okay? Now, I'm going to take the square root, and I'm going to split it up into 2. Okay, so I'm working my way back to the left. Sorry, I kind of ran out of room here. So I'm going to get 1 plus 7, because that's the square root of 49 over 4. And I get 1 minus 7 over 4. If I simplify both of those, I get 2, and I get -6 over 4, which is -3/2. You could also have -1.5 there, and that would work really well. Okay? Last one in terms of quadratic formula that we're going to go over is, oops, wrong button, is 3x squared minus 4x minus 1 equals 2. And the difference here is that we are not equal to 0 over on the other side, okay? So that's equal to a 2. So currently we cannot use the quadratic formula. However, if we want to use the quadratic formula, we can simply get it equal to 0 by subtracting 2 from both sides, okay? So that'll turn it into 3x squared minus 4x minus 3 equals 0. Now that we're equal to 0, we can identify our A, our B, and our C. So seeing that, I can now plug them into my formula. I'm not going to rewrite the quadratic formula here. Okay, I'm just going to plug in. Hopefully you've got that written down somewhere in front of you. And putting that all over 2a. Again, I really strongly suggest you use parentheses to plug in for the variables, okay? So taking a look now, we're just going to kind of go ahead and start simplifying. I'm actually going to use a calculator for this one because, honestly, totally think it's way easier. So I'm plugging in what's underneath the squared into a calculator too. So yes, I did see a question up there about using a calculator. That is totally okay. And it looks like we get 52 under the square root this time. Okay, so we're going to change a couple things. -4 turns to just +4. We get 52 under the square root and a 6 under here. Okay, this is a situation in which we don't have a perfect square under the square root. So when we take the square root of it, we're going to get a decimal. So we're going to do 4 plus 7.21, because that's the closest we can get on the square root of 52, and 4 minus 7.21, all over 6. Okay. Folks, you do need to be a little bit careful after that. Like, I actually like to simply do 4 plus 7.21 by itself next. I don't like to type it all into a calculator, okay, because we want to be careful with order of operations there, and I want to be careful to make sure I've got some things that I can check there, but there's always ways to do it. You've been doing enough of these that you probably know what's comfortable for you. You can't leave your answer like this, okay? You have to actually do the division in both of these cases, okay? So like on the bottom here, we're going to get negative 0.5, we'll call it 4 because we want to round. And then same thing on the top, we're going to get 11.21 divided by 6, and that's 1.87. A lot of rounding went on there, okay? I'm going to go through some of those questions before we get to the very last one, okay? Drew asked if we round to the hundredths. Yes, please, round to hundredths. Hundredths is great, so that's 2 after the decimal place. You can definitely 100% use the calculator. Adam has asked about a very specific problem. I don't think I would put anything like that on a test, so yeah, no. I think the most you're going to see is kind of like this one, where, yeah, if we got to use the quadratic formula, it's probably, you know, maybe it's not equal to 0, but we're talking about one little subtraction to get it equal to 0, so that's probably it. And I know Noah asked, we're going over all the completing the square stuff. So completing the square, and I didn't use this terminology a lot in class. Completing the square is actually exactly what we did on this one. So I brought that back up on your screen. Okay, that's exactly what we did here. Basically, that whole process of turning that number into a 6.25, that's what completing the square is. So basically, it's solving without the quadratic formula. So in the end, you need to know how to solve without the quadratic formula problems like, this one, okay, where maybe that third number isn't quite what you want it to be. And you need to know how to solve with quadratic formula. And in quadratic formula, the biggest worries are that you know what the quadratic formula is, and that, like in this one, you make sure it's equal to 0. Okay, those are kind of our big issues there. Okay, I think that pretty much answered most questions that most people had. We do have one more to look at, okay, and that is using the discriminant, okay? So basically, Tenny actually just asked a question too. Tenny asked about what about absolute value? Absolute value I actually did right away at the very beginning. That was this one, okay? So if you're not sure on that, go ahead and this should post relatively quickly, so feel free to go back and watch that again, okay? Last one is the discriminant, okay? So the problem itself I have is 2x squared plus 3x minus 1 equals 0. For the discriminant, your only goal is to basically be able to write either 2 solutions, 1 solution, or no solution. Okay, or if you prefer no, 0 solutions. I think I actually specifically tell you tomorrow there's going to be 2 of these, and all you're going to have to do is write a 2, a 1, or a 0 on the line for the number of solutions. Again, you're not solving here. Okay, so instead of doing the whole quadratic formula, all you're going to use is the b squared minus 4ac part. Okay, and after you do that math, if it's a positive number, then you're going to write 2 because you have 2 solutions on your line. If it's a 0, you're going to write 1 because you're only going to have 1 solution. And if it is a negative, you are going to write 0 because that'll have no solution. Okay, so for this particular example, I'll switch back to red. My A would be 2, my B would be 3, my C would be negative 1. Okay, doing the math, b squared minus 4ac, I still use parentheses, even if I'm just using discriminant. That gets me a 17. Okay, so then I look over at my handy-dandy little chart over here, and it says if it's a positive number, I'm going to have 2 solutions. I don't have to finish the problem. I don't need to know what those 2 solutions are, so all I would write tomorrow is 2 solutions. That's it. That's the whole thing for discriminant, okay? We're not actually doing it, okay? Folks, your test is very, very short. It is only 11 problems, and 2 of those are discriminant problems, okay? So, I mean, pretty close to a lot of the stuff that you saw here is what you can expect tomorrow. If you're watching this later, or if you have additional questions that I was unable to address, I should be at school early enough for you to at least quick ask me those questions before school starts, for those last minute ones anyway. Grant asked a good question on how do we know if it's discriminant. Really, I'm very clear tomorrow on exactly what you should be doing, okay? Like I'm going to, as William then responded, I'm going to tell you, okay? So really, I'm going to tell you when you can use quadratic formula, when you cannot use quadratic formula, and when it's discriminant, and when it's not, okay? Okay, so if there was anything that you missed or anything that you didn't get a chance to see, if you weren't here for the entire thing, this thing will post as soon as I'm done streaming. You should be able to go back and rewind and watch those things again, okay? And you should be able to figure everything out, okay? And again, if you got last minute questions, feel free to pop in the morning, okay? Thanks for those of you that were here. Thanks for taking some time out of your evening to do a little math. Make sure we're ready for test tomorrow. And I will see you guys in the AM.